Hello students, welcome to Sort of Sus classes. Today the problem that we want to solve is let fx be a non-negative differentiable function on a comma b closed in R such that f of a equal to 0 and f of b equal to 0 and mod f prime x is less than equal to 4. L1 and L2 be the straight lines given by y equal to 4x minus a and y equal to minus 4x minus b. Then we have to see if y lies above the lines L1 and L2 and below the lines L1 and L2, and the other options are integral AB less than b minus a square fx. The point of intersection of the lines L1 and L2 lie on the curve fx. So this is a multiple select questions and we have to analyze each option one by one. Firstly, what are intersection points? Now the graph of the lines something like this is 4x minus a and this is 4x minus 4x minus b. So what are the intersection points? The intersection points are a plus b by 2 just by solving the equations and twice b minus a. Now f prime x is less than equal to 4. Suppose x belongs to a comma a plus b by 2. Integral of a to x f prime x is less than equal to integral of a to x 4 f prime t dt. I'll just call it, this is 4 dt, which implies f of x is less than equal to 4 times x minus a, just because f of a is equal to 0. This follows by the fundamental theorem of calculus. Now if x belongs to a plus b by 2 comma b, we have bx f prime t dt less than equal to bx 4 dt. So fx minus fb, which is 0, is less than equal to 4 times x minus b. So fx is less than equal to minus 4 b minus x. So let gx equal to 4 times x minus a if x belongs to a comma a plus b by 2 and minus 4 times b minus x if x belongs to a plus b by 2 comma b. Since g is the maximum of the two lines, g is the maximum of lines L1 and L2, and we have fx is less than equal to gx, therefore f lies below L1 and L2. Immediately, if we move back to the question, A is a correct option and B is wrong. Next up, let us try to see what integral of a to b fx dx looks like. Now this will be less than equal to integral of a to b gx dx, which is equal to integral of a to a plus b by 2 gx plus integral of a plus b by 2 to b gx dx. Now integral of a b fx dx is hence less than b minus a square by 2 from the first of the previous integrals and b minus a square by 2 from the second, which makes it b minus a square. We get this by simply integrating what we had earlier, integral of a to a plus b by 2 gx dx, and it's a simple integral because the polynomial gx dx is just a 1 degree polynomial. You can just compute it quickly. So it is giving us that integral of a to b fx dx is less than equal to b minus a whole square. Therefore C is correct. Now suppose a plus b by 2 and b minus a, twice b minus a, belong to the graph of x comma f of x. Since the graph looks somewhat like this, and this is the intersection point of the two lines. Now since f always lies below these points and f prime of x is less than equal to 4, f cannot have a steep slope at any point. Since f prime of x is less than equal to 4, the function f can never really go above these lines, and hence it cannot have a point of differentiability at this point. This can be easily proved also by using Lagrange theorem or mean value theorem, I guess. But from the graph it is actually clear, and since this is an MCQ question, we should actually give graphical arguments because it saves a lot of time. So D is incorrect. And moving up to the question, we cross D out and correct C. So A and C are correct and B and D are wrong in this question. Thank you.